Okay, we hit done. Let's go to view. So welcome in. I'm just taking attendance as I let people in. I already see one name. I recognize the name roster, so I'm trying to save them. I need to let them know that I don't see them on my roster. Let me let people in because I have announcements I want to make, but just give me a moment. Just taking attendance. A B C D E. Okay, so this is another name I don't see. A B C D E. I think that might be his last name. It's backwards. Okay. All right. So welcome in. Welcome in. Let me see. So yeah, I'm just taking attendance. We got like a lot of students, so it just takes a little while. All right here. Okay. Okay. And I want to say that you should have access to be a poll available. If it's not, I will get it up and running as soon as I finish this. So just check out the poll, and because that's how we're going to move forward today. I definitely see some familiar. Let's see. I just did. Man, we got a lot. It's no joke. Like you guys talk for real, for real. It's all good. You're doing what you're supposed to do. Okay. And so only one I don't see on the roster. Let me just let them know. Okay, let me send them a chat. So greetings. Greetings. I don't see you on my roster. Is your student name? So yeah, it is a good idea so that your ID for Zoom has your student name. Because like when there's only one person in right now who hasn't got attendance credit. I just messaged them. I think I got everybody. So let me see, as far as announcements. So one thing that's a little bit different today. Okay, so there's a couple of things. There is a poll available right now. Okay, so I don't know if you can see it or how to get you to see it, but there's a poll. So check out the poll. I don't know if you can see it. I don't want to end it though. Let me check the chat. Okay. And feel free to unmute yourself if you have questions as we go about. The other thing I kind of wanted to let you know about today, I am live streaming this presentation to my YouTube channel. I'm gonna push. Oh, there it is. Oh, okay, relaunch. I'm just gonna relaunch the poll. So you just have to do it again because it wasn't updating on my end. Okay, so there's a poll. Basically, it's like it says, "What would you like to do today? Which of these options? Which of these options do you most resonate with?" I want to say last time we did make our way through section 1.7 inverse functions. Now I'm open to doing it again because I think that's what I did with my earlier class. Or let me get this student. See, this is why I like Blackboard much better. It's much more smooth. Come on. close, let them in. And I'm gonna hop back to the poll. To the lecture, y'all still want to go to the lecture? Okay, yeah, most people, it seems like most people want to go through the lecture. I thought we made it through most of it. I'm not really sure where we left off.
Is it required to stay today as attendance, or have I already been checked?
Once you get into the Zoom, you've gotten your attendance credit. So that's suffice. Yeah. So this
Okay.
is so just on any given occasion, you just got to get your attendance credit. So yeah, you're not obligated to stay. The presentation, the lecture that I did. Let me see. I think we. Let me get the student Rabate. I remember. Yeah, there he is. I want to say that we made it through. That's totally distracting. I gotta suppress. Let me see if I can do it now. Hang on, it's totally distracting me. Meeting settings, and I thought I had turned it off. General. Okay, I had to do it later because I don't see it in the main thing. Okay, that's fine. So I think the poll, you guys, most people wanted to go through the lecture again, but I want to say we got through most of it on Wednesday, and this lecture is recorded. So I think I'm just going to make an executive decision and go ahead and kind of start making my way through the homework, right, for this section. So for section 1.7 on inverse functions, we do have a homework and quiz already assigned. Also, okay, another piece of important information is that the main thing that you want to make sure that you have been able to do right now is go ahead, make sure that you've gotten full access to the homework assignments on Pearson. Again, if you're using Pearson and you're using the exact same book from the past, you can just use that login information and you do not have to purchase one. That is distracting me. It keeps breaking my train of thought. Let me see. And I thought I had changed that option, but it's okay. It keeps kind of like resetting my settings. There was something else. Whatever it is, it'll come up as needed. So today, what I think I'm going to do, I'm going to start making my way through the homework associated with section 1.7. So again, this session is being live streamed directly to my YouTube. So, you know, it's there. You have can watch it. I think I got him already. Just check real quick. Cool. But yeah, so what I'm going to do, I'm going to share my screen. That's fine. You can start that. And then I'm going to hop over to Pearson. And yeah, I'd like to get started. Like let's just kind of make our way through some of these homework questions. Okay, so we can start with section 1.7 because that's what we're working on for this week. There are a total of looks like 17 questions. So we're going to start at question number 1. Now, again, I'm just doing this to kind of fill the space or fill the air. Hang on, let me see. I think I can change that. Yeah, that's better. But yeah, we don't necessarily have to go in this order or work on this specifically. I'm just doing this to kind of fill the air. And like, honestly, I mean, I want to say that you can open up your homework and work alongside me, but you'll probably have the same questions, but it'll be different numbers, right? So feel free to stop me if you have questions about anything. We could talk about anything, but otherwise, I'm gonna just kind of start making my way through as many of these assignments as many of these questions as I can. Okay, so it says the graph of a function is given, and we're asked to use the horizontal line test to determine whether f is 1 to 1, right? So when we talked about this before, again, the horizontal line test means that no matter where you draw a horizontal line, it only touches the graph once, right? So if we look at this, no matter where we draw a horizontal line, it'll only touch the graph once. If we can draw a horizontal line and it touches the graph more than once, that's an example of something that fails the horizontal, right? So is this 1 to 1? We would say yes, right? Because no matter where we draw a horizontal line, it only touches the graph once. I'm going to hit final check. I'm going to the next question. Okay, here we're asked to use the horizontal line test to determine whether the function is 1 to 1. So clearly, right, you can draw a horizontal line. It'll touch the graph more than once. So then is this function 1 to 1? We say no, all right? So one-to-one, let me see, passing the horizontal line test is the same, a function being one-to-one is the same as a function having an inverse, right? And so let's kind of keep going with this discussion. So if a function f has an inverse and f of -7 is 3, then what's inverse of 3, right? So if a function has an inverse, then basically what the inverse does, it kind of like undoes the function. It's like the opposite or the reverse of the function. So if this function takes negative and maps it to 3, give me just a moment. I'm gonna, I think I got him already. No, I have not. Let me give him credit. Okay. So what an inverse does is basically what it does is it undoes it does the reverse of what a function does, right? So if this function takes -7 and maps it to 3, then if we say f inverse of 3, what that's going to basically do the reverse. It's going to take it from 3 and put it back to the -7. So this one should be quick and easy. It should just be -7. I'm going to go on to the next question. So here we're asked to find f inverse of f of 481, assuming that the function is one-to-one. So again, this little circle, this little open circle from College Algebra 1 means composition of functions, the second function inside the first function. And the whole point is that an inverse function composed with the original function, they basically cancel each other out, right? So if f inverse is essentially canceled by f, the only thing that's going to be remaining is 481, right? So there's nothing to calculate there. It's just a concept. We're like flying through these questions. I might move ahead. Like if we finish early, which it seems like we will be, I might go ahead and get started on the next section. Next week, we meet Wednesdays and Fridays. So now I think this next week, Monday is a holiday, is King Day. The school is closed. We don't normally meet on Monday, so it doesn't affect us. But for your other courses, but we'll still be here on Wednesday and Friday. So let's see, for f of x equal to this, find each of the following. Okay, do I need to write anything? I feel like I can get through this without writing things down. So for instance, we're just evaluating this function, right? So when x is 0, okay, so if we plug in 0 into the original, 0 cubed is 0 plus 9. So that one is just going to be 9, right? So if f of 0 is 9, and then they ask us to find f inverse of 9, is basically going to work backwards. It's going to undo what we just did. So it should take us back to 0. No theory, right? And then if we have f of f inverse, again, they cancel each other out. Oh, my battery's getting low. That should give us 688. I can't charge it while I use it. That's fine. I'll get that going later. So find f compose g and g compose f and determine whether the pair of functions f and g are, right? So we're given this f, we're given this g, and we want to verify that these are inverses. So in order to do that, I think we said something to the effect of, in order for these to be inverses, f compose g needs to equal x, and g compose f needs to equal x. And then, that's how we verify that two functions are inverses of each other. So what I'm going to do, I'm going to take a copy of this. Let's go here. And come on. I want it from like here. This is kind of like overkill a little bit. Let's copy. That's fine. We're going to hop over. And let's actually do a blank. Come on. There we go. Quickly. All right. So here's the question that we were just looking at. Oh man, they changed that too. They keep changing stuff. Okay, that's fine. And one other thing that I like, my template, I like my paper. I like to write on graph paper, and I usually go spacing of about 2. Done. Okay. So again, for this f and g, basically we want to verify that these are inverses of each other. Okay. So first, let me start by getting a copy. Let me move this somewhere else. It's kind of in the way there. So, okay, let's start by getting a copy of the originals, right? I know we have that, but I like to do So we have f of x equals 2x plus 4. We have g of x equals, now on top we have x minus 4 over 2. We want to verify that these two functions are inverses of each other. So we just do f compose g, that should equal x, and then we do g compose f, and that should also equal x, right? So first we want to consider f of g of x. So we're going to put g inside of f. Get off this table. This table makes a lot of noise. Okay, so we want to consider f compose g, right? So then what this means, we're doing f of, now g of x is that x minus 4 over 2, right? So what we're doing, we're just basically rewriting f like normal. We're just rewriting f like normal, but then we're replacing all the x's in f with the green thing. So here's 2x plus 4. So the first thing I did was replace the x with a blank parentheses. And then what color goes into the blank parentheses? The green thing. So then we say x minus 4. Okay. So now if we simplify, you can basically, you got a 2 on top, cancels the 2 on the bottom. And then after that part, you have you can do the associative property of addition, and this negative 4 is going to cancel this guy. And that just leaves us with our desired result of x. Okay. So then we need to do the other direction. We did f compose g, now we need to do g compose f. Okay. So then this is going to be g compose, now f of x is that 2x plus 4. Okay. So then g of x is x minus 4 over 2, right? So again, the first thing I did is I replaced the x with a blank set of parentheses, and then what goes into the blank? The fuchsia thing, 2x plus 4. Okay. So then when we do this, associative property of addition, this can cancel this. We can just essentially lose the parentheses. Then we're going to have 2x over 2. So this 2 is going to be canceled by this guy. I'm not really showing all the steps. I'm just doing them. Okay. I feel you can handle that. Right. So now we've shown that f compose g equals x and g compose f equals x. So then that's how we show the two functions. Okay. So now we verify that they are inverses. Let's go back to Pearson and answer the question being asked. Okay, come on. So let's see. Okay, so I think this is just x. This is also x. And those are the two conditions we needed. So then we can say the first one that they are inverses of each other. Okay. Now I want to say there's a quiz as well. We can kind of make our way through that and get a sense of that as well. Let f be this and g be this. G, what is g compose f? Let's write this one out. Let's write this one out. I don't want everything though. I just want from like, come on. I'm gonna go from here. Yeah, this is all I need. Okay. Let's just go ahead and drop this into the next page. Okay. Oh, we're asked to find, I think it was G compose F. Give me just a moment. I don't know if this person already got attendance credit or not. Plus their last name isn't showing, so now I don't see him. I'm not gonna worry about it. Okay, I just let him in. Okay, let me check the chat. Yeah. If you've completed your assignments, that's a good thing. If you can get ahead, I don't think I'm not sure if I already did the next one or not for you guys. Hopefully you were able to like find your way. Let me go back to Pearson real quick, right here. They asked for G compose F. Okay. Now, they asked for G compose F. Okay. I'll put question mark. So let's do this. G compose F of X. What does this mean? Again, this means the second function inside the first function. So this means G of F of X. That's what it means. Okay, so this is going to be G of, now what's F of X? Is 2 over X. Okay. So then all we do is rewrite G like normal. Oh, it's the same? Okay, so then 2, but now we replace the X with the fuchsia thing. So we got 2 over X, right? Okay, so then, so if you, this is like a complex fraction. So when you have one fraction inside of another in this form, you can basically do keep, change, flip, where we keep the numerator, change division to multiplication, and flip the denominator, right? So if we do keep, change, flip, we're going to get 2 times, now it's going to become X over 2. All right. So then 2 times X over 2, I think it should be clear what happens there. This cancels this, and we're left with our desired result. Now again, these just happen to be working out in this fashion. They don't always work out this way. Okay. So then G compose F in this case is just going to be X. I'm going to hop back over to Pearson. We got a result of X. I need to do it. Okay. See, we're almost done. We only got like about 20 minutes left. It'll be over like that. Since these are the same, I'm just gonna go ahead and put in X again. Okay, I mean, we could write it out. We probably should write it out, but I didn't. Are F and G inverses of each other? We're gonna say yes. Okay. So it says the graph of a one-to-one function is shown to the right. Draw the graph of the inverse, right? So given the original function, so let's look at this. So given the original function in blue, the graph of the inverse is going to be, basically, if you take this graph and rotate about that line, that diagonal y equals x. One way that we could do this, we can like kind of identify a lot of those key points and then switch the order pair, right? For instance, one point on the graph is the point 0, 1, it looks like. So then a point on the inverse is going to be 1, 0. So you, like, if you wanted to just plot the points, you could just list out those order pairs and then switch them, right? But conceptually, we're just basically flipping over the diagonal y equals x. So the one that does this, it looks like is what, D, right? Let me see. We got people still. Got a good amount. Cool. Okay. Do y'all agree with D, or what do you think? Something else? Can you see these? What do you think? A, B, C, or D? Okay, I'm going to go with D. Graph the inverse of the one-to-one function. You see the function? No function there. It says choose the correct graph. Choose the correct graph that shows the inverse as a red dash curve. The graph of F is shown as a blue solid curve. So all the blue solid curves are the same. If we were to rotate about the diagonal y equals x, which red graph is correct? Which one has been rotated about the diagonal y equals x? A, B, C, or D? I am going to go with D. Okay. And again, like if you need an explanation or if I need to go deeper, just let me know. Like explain more. Let's see. The graph of a one-to-one function is given. Draw the graph of the inverse function. For convenience and as a hint, the graph of y equals x is also given. Right? So they gave us a whole bunch of ordered pairs, right? So this is what I meant by like, we can take those ordered pairs and just reverse them. So we can quickly plot. For instance, if the point -2, 1 is on the graph of f, then that means that the point 1, -2 is on the graph of f inverse, right? You can just, for all those ordered pairs, you can just switch them around, and that'll give you the graph. And basically, it's going to be symmetric about that diagonal y equals x, right? So then, I think the only one that does that, which one is symmetrical in a proper sense, is going to be D. Okay. Yeah, I think we're kind of moving. We're cruising, moving and grooving. Okay. So for this function, answer parts A through D below. Determine algebraically whether the given function is 1-to-1. Let me think about it. Did we not talk about that? Okay, so there's something that I kind of want to mention, but I want to see first. What I want to do, I'm going to go to get more help, and I want to click on view an example. So, okay, let me mention this. For the following reason is why I vouch for Pearson, right? So say you're working through this and you get stuck and you're working by yourself and you just don't know what to do, right? Like I'm not stuck, but I want to use something, but I'm not sure if that's the way they want me to do it. So I'm gonna pull something up. Now, when you click on this get more help in this lower left-hand corner, you have these options that pop up. You got this help me solve this, view an example, blah, 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 blah. I'm about to use the view an example. It pretty much is going to be the exact same question with different numbers, and they'll give me an explanation as to how to think about this. A lot of the questions have a video tutorial that is assistance. This textbook is a digital e-copy of your actual book, right? And then lastly is the Ask My Instructor, where basically when you click on it, it'll send me a screenshot of the very question you're working on, or it'll come directly to me. I'll load it to my tablet, think about it, make a response, load the response to YouTube, and send you the link, right? So you can actually make use of the Ask My Instructor. I'm going to click on the view an example. To determine algebraically whether the given function is 1-to-1, yeah. To do this, let x1 and x2 be two numbers in the domain. Yeah, so now right here, it says suppose, so in order for this to be 1-to-1, every y has to correspond to exactly one x. You can't have one y correspond to two different x's, right? So basically, if we have to show uniqueness. So if we consider two y's that are equal, then that should imply that the two x's are equal. If they aren't, okay, so I just wanted to make sure that this is what they're doing. So then what I'm going to do that with this example. So let me get a copy of this. We have f of x equals 30 minus 5x. And they ask, is it 1-to-1? Okay. All right. I know I got all this background noise. This is a question number 11. 30 minus 5x. Okay. So I'm going to hop over here. 30 minus 5x. I think it's question number 11. That's not an 11. I don't know what I was writing. This is question 11. It comes from 1.7, question 35. Question 35. And 30 minus 5x, right? Okay. So we have f of x equals 30 minus 5x. So then we're asked, for part A, we're asked, is this 1-to-1? Question mark, right? So in order to show this is 1-to-1, we have to show basically, if we have y1 equal to y2, that implies the x1 is equal to x2. So let's see this now. So instead of y1 and y2, we're going to say consider f of x1. And we're going to set that equal to f of x2. Right? So then what we're going to do, we got this 30 minus 5 times x1. That means that should be equal to 30 minus 5 times x2. Right? So then we can use algebra, like we can subtract 30 on both sides. So they'll cancel. I'll continue over here. So then we'll have negative 5x1 equals negative 5x2. Then we can divide both sides by negative 5. And we finish with our desired result that x1 equals x2. So this is like how we show uniqueness. We show, given that two different y's are the same, that implies that the corresponding x's are the same, right? We're going to see an example, hopefully, where this is not false, right? But this one is a true. So let's look at it. So is the function 1-to-1? This is an example of something that's yes. What happened there? Let's try that again. Is this 1-to-1? We would say yes. Okay. So then if the function is 1-to-1, find the inverse. Okay, let's go find the inverse. We got this, all right? We're asked to find the inverse. Okay. My beautiful handwriting. Okay. So the original was, let me just get a copy of this guy. Copy. Now, we may or may not have done this together, but I'm just going to walk you through how to find the inverse of a function algebraically. The first step is we want to replace f of x with y, right? So we replace f of x with y, so we say y equals, and then just everything else comes down. Next thing that we want to do is switch the x and the y. So the y switches to place with all the x's. So then now we're going to have, let's do this, x equals 30 minus 5y. Okay, and I'm going to just highlight these guys in blue. So again, all we did was switch the place of all the x's and the y's. Okay, so then the next thing that we want to do is solve for y. Right? So if we're going to solve for y, first thing I'm going to do is subtract 30 from both sides. Let's do it this way. I'm going to subtract 30 from both sides. These two cancel each other out. We have what? This x minus 30. We have a negative 5y. And then I'm going to divide both sides by negative 5. Okay. So then I'm just going to rearrange it. So now we get y equals, I'm actually going to distribute that negative across. I mean, okay, just to keep it simple, we get this x minus 30 over negative 5 over negative 5. But you can actually distribute that negative into the top. This is the same as, I'm going to write it as 30 minus x over 5. All right. And then the final step is replace the y with f inverse. This is now our inverse function. 30 minus x over 5. Okay. Let me see for part A, and I just want to put a check for that. Okay. So the inverse, we got 30 minus x over 5. Okay. So let's hop back to Pearson. Okay, I'm kind of running out of space here. So we got keyboard. Are you still alive? Let's go like this. We're going to hit the division. We got 30 minus x over 5. I'm going to hit enter. Again, if anything is not clear, if I need to go back, you just got to stop me and speak. Then we're asked to sketch the graph of the function and its inverse on the same coordinate axis. So these are, so we're going to click here. We got 30 minus 5x, so that's really just a linear function. Highest exponent is a 1. Click to plot your first point, so I just kind of click somewhere. Can I edit by typing? Okay. Thought I made that option available. So let's see, for instance, when x is 0, 30 goes off the screen. The y-intercept is 30 and has a slope of negative 5. What about when x is 2? When x is 2, y is 20. Let's do when x is 3. When x is 3, we're at what, 15? So then we're at the point 3 comma 15. I think it's about 1, 2, 3, 3 comma 15. Okay. And then I'm just gonna do when x is, what's a simple one? What if we did when x is 10? When x is 10, no, that's too much. 8 or 6. Okay, when x is 6, right? So when x is 6, y is 0. So that's the y, that's the x-intercept. 4, 5, 6, y is 0. Oh, can I see it? Okay. Yeah, 6 comma 0, right? I think this is okay. Oh, that's the first one. And then we need to graph the inverse. So now we plotted, I think we said what, 3 and 15. So now we can also plot 15 comma 3. We plotted 3 comma 15. Now we can plot 15 comma 3. Just switch the order here. So 15, there's 3. I think 15 is about here. 15 comma 3. And then we also plotted 6 comma 0. So then the second point here can be 0 comma 6. All right. 0, 6. And I think the other one's good. I'm gonna hit save. Okay, I think these are okay. Let's just go with it. Cool. Okay, let's hang out for about 5 more minutes. So get the domain and the intercepts. The domain. Give the domain of the function as 1 to 1. The domain, so the very left of the field are reals. I'm going to write this in interval notation. I'm going to do parentheses, negative infinity up to, come on, infinity. What was the domain that we got? Intercepts, the x-intercept and y-intercept. The x-intercept was what, 6 comma 0? 6 comma 0. And the y-intercept, when x was 0, the y-intercept was what, 0 comma 30. 0 comma 30. Okay, I'm gonna go with these. Let me see. X-intercept, right? When x is 6, did I type in? Oh, okay. So I did them as order pairs. They just want the numbers themselves. So that one, x-intercept, they just want 6. And the y-intercept, they just want 30. Okay. Let's see the time. So the domain of the inverse function happens to be all reals. Okay. So negative infinity up to infinity. Okay. And then, so it kind of reverses, right? So that means the x-intercept should now be 30 and the y-intercept should be 6. So this will be 30 and this one will be 6. Need like 5 more minutes. Determine whether the function is 1 to 1. Okay, let's try that same technique that we did just a moment ago. Let's see what happens. First, let me just get a copy of this guy. Come on. Take this. Okay. We're asked to determine whether this function is 1 to 1. So in order for it to be 1 to 1, the following should be the case. If we say f of x1, that's equal to f of x2, we should be able to finish with x1 equals x2, if it is 1 to 1, right? So then we're going to get 7 minus x1 squared inside the radical. 7 minus x2 squared inside the radical, right? All I did was replace the x with x1 and x2. So now, let me think about it. So to get rid of the square root, first thing we can do is we can square both sides. Okay, and I think those will be okay for now. So then we get 7 minus x1 squared equals 7 minus x2 squared. Okay. Let's go ahead and subtract 7. They cancel. So then we have negative x1 squared equals negative x2 squared. I'm gonna go ahead and multiply both sides by -1. So I'm just gonna say times -1. Times a -1, right? So basically the negatives are gonna cancel. So here's the main part. Now we got this x1 squared equals x2 squared, right? So then to get rid of that squared, we gotta do square root, right? But then when we do square root, what do we need to introduce? We need to introduce plus or minus. Whenever we do even root, we need to do plus or minus, right? So because of that, right, even though the squares are canceled, now we finish with plus or minus x1 equals plus or minus x2, right? So what this is saying is that x1 equals x2 and x1 equals negative x2, right? So you can find a positive number that'll match another positive number, and you have the positive number that's going to match the negative number. So when you get something like that, this is an example of something that is not one-to-one. So we would say this is not, every y does not correspond to exactly one x. So in other words, you could find 2 different x values that map to the same y. 7, if I want that to be a 4, 3, you could do, like, I was gonna do plus or minus the square root of 3, but that's a little bit overkill. But you could find 2 different x values that'll produce the same y. But it's namely because of that plus or minus, right? So we would say this is not one-to-one. Okay. Let's see the time. That's about it. Let me hop back over to Pearson and check this. Is this function one-to-one? We would say no. Okay. So we actually did pretty good. We got through most of the questions in like a 50-minute window, approximately. Yeah. So with that, on that note, we're going to end the session here. I'm going to go ahead and make it available on our Blackboard page. Okay, so I'll load that momentarily. If there aren't any further questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care, guys. I'll see you next Wednesday.
See ya. Thank you.
If you start that podcast, I will most definitely tune in.
Oh, I received that as confirmation. Yeah. Yeah. Right.
It was actually very interesting what you was talking about in
regard to what? Which part?
oh,
Which one?
in the first one, you posted before the class. Oh, you was just talking about
Yeah, just like random stuff. Because I do go on, about like metaphysics.
just like the rant. Like,
yeah,
it was good to have them like in between the math because I don't know.
I feel it. I get it because like I know math can be so like linear and logical, and like you gotta break up the energy. Yeah.
But thank you though.
Yeah, my pleasure. Okay, have a good weekend.
You too.
Yeah. All right.